no gravitational wave, and now, a gamma ray burst or black holes merging, and you can see here the gravitational wave.
这期视频来到了法国里昂的先进材料实验室 LMA， 他们主要参与制作了引力波探测器 Virgo 以及 LIGO 的光学镜面部分。
So the principle is very, very simple. There is a laser beam here, okay, a beam splitter that splits the laser beam in two arms, okay, but in with two equal beams, okay, okay. So two beams, there are two mirrors.
这个就是引力波探测器的基本原理演示了。一束激光会经过分束器打到两个反射镜面上，这两束激光会重新融合产生干涉，然后汇聚到探测器上。这里你所看到的这两块反射镜面就是一会儿我们要参观的内容了。镜面的反射图层部分呢，就是由这里制作完成的。这个就是探测器所看到的影像了。一旦有引力波的出现或者仪器产生振动，都会对这个图形产生扰动。通过探测这些扰动，我们就能追溯出引力波事件了。面前的这三块镜面就是引力波探测器所要用到的光学器件了，而这已经是加工好的备用品。一旦 LIGO 或者 Virgo 的设备出现问题，就会将它们替换上去。
On the shelf, just in case of LIGO or Virgo, we need a new mirror because of damage, and so I don't know. So they are, as you can see, they are still 45 centimeter in diameter, but they are 40 centimeter in thick, and 40 kilogram. So.
But you don't have to make such kind of mirror by yourself. You only have.
We buy the polished blank. Okay. So the blank is manufactured by Germany. The polishing has been carried out by, I think, in US, or in Deutschland, I don't remember. And then we coat the surface. So we coat on the best surface, we coat the height reflective coating, and on the other side we coat an anti-reflective coating. And the coating is, I don't know if you can see the yellowish. It depends on the incidence. There is a disc in the central part of the.
I just noticed there is.
You can see by eyes, but I don't know if the camera it's very visible. And this disc is the coating. So it is the height reflective coating. 4 mirrors in the detectors. There are mechanical sound interferometer. There are two arms, and in each arm there are 2 mirrors to make the fabric cavity in order to increase the power.
Yes.
And we produce this mirror, and we have very very high reflectivity, very close to 100%. In order to have the more powerful intensity inside the cavity, and that's it's the best way to have a very high sensitivity with respect to the cosmic events, gravitational way.
如果你们注意到他说的话，他们实际上为每个引力波设备制造了4套镜面，其中2套位于引力波探测器 L 型支臂的末端，还有2块镜面会放在 L 支臂的中间，产生一个法布里 Parrot 干涉仪的结构激光会在内部不断反射，实际上就是增加光线的长度。正是因为这个仪器，使得它将每束激光的有效传播距离从探测器管道长度的4公里增加到1000公里之多。这对引力波探测是非常重要的，因为干涉仪的这个臂越长，引力波对其影响就越敏感。那即使是微小的引力波，也会更容易的被探测到。
So it's the first generation of suspension. You can see steel wires. That's so the wire go all around the mirror, and so the mirror is suspended thanks to these wires. Now the new generation use silica fiber, so optical, mainly silica fiber, optical fiber, and they are glued on the side of the mirror. and the loss, the mechanical loss, the vibration are very lower.
由于光路长达1000多公里，要保证光线最终精确打到探测器上，所以镜面上配置了角度调整设备，确保光线是对齐的。
And I saw you touch somewhere.
Yeah, wired. It's just for the control. You can see a white plastic part behind the mirror,
Yes.
and there are a copper wire around this plastic. So it's basically electromagnet.
Yeah.
So you can by adjusting the current, you can tune the magnetic field, and you can there are some magnet glued on the rear face of the mirror, and you can control push or
okay.
yes,
I see.
pull the so yes, and you can adjust the orientation of the mirror. The next generation, we are working on a new improvement of this optic, and the baseline is a mirror of 100 kilograms.
Wow.
So it's very heavy.
Amazing.
Yeah. So that is the core activity. It's business.
好了，这就是这期视频的内容了，带大家看了一下引力波探测器的镜面。如果你喜欢物理，喜欢天文，别忘了加关注。我们下期视频再见吧，拜拜。